Rivers are not supposed to disappear. They follow gravity. They follow terrain. They follow rules scientists understand. And yet, in some places on Earth, entire rivers vanish. No ocean, no lake, no visible underground exit. The water simply stops existing, at least on the surface.
Water is one of the most studied elements on Earth. Its movement follows gravity. Its behavior follows rules that scientists understand very well. Rivers flow downhill toward oceans, toward lakes, toward basins. This predictability is what makes water reliable. But in some places, that reliability disappears because there are rivers that do not reach the sea. They flow normally, they follow the land, until suddenly they vanish. Rivers are expected to follow gravity. They move from higher ground toward oceans, lakes, and natural basins. This behavior is predictable. It can be measured, and it follows physical laws scientists understand very well. For centuries, humans have relied on this consistency. Rivers shape landscapes. They define borders. They support ecosystems. But in several places on Earth, this logic breaks down. Water reaches a specific point. It slows, and then it disappears. Entire rivers vanish into the ground, not through tunnels, not through visible cave entrances, and not through any clear destination. There are no surface channels, no obvious paths, no immediate signs of where the water continues to flow. To someone standing nearby, it appears as if the earth itself is absorbing the river. When scientists encounter this phenomenon, their first instinct is to track the water. If it disappears, it must be moving somewhere. One common method is the use of colored dyes. The dye is released upstream. Then researchers wait, sometimes for hours, sometimes for days. Sensors are placed underground. Water pressure is measured. Flow rates are calculated. Satellite imagery is also brought into the analysis. In some cases, the water reappears far away. It may emerge as a spring or feed into another river system. Sometimes, it resurfaces hundreds of kilometers downstream. But in other locations, the water never returns. No springs are detected, no underground outlets are found. Despite extensive monitoring, the trail simply ends. One leading explanation points to underground landscapes known as karst systems. These regions form when slightly acidic water slowly dissolves rock. This process takes place over thousands and even millions of years. As the rock weakens, networks begin to form. Caves, cracks, channels, hollow chambers. Some of these systems can stretch for hundreds of kilometers. In theory, they are capable of transporting large volumes of water without visible surface rivers.
This explanation works in many known cases, but it does not explain everything. In several regions, the scale of water loss is far greater than these systems should allow. Even the largest known cave networks appear too small to account for what is missing. If these systems cannot contain the water, then something else must be holding it.
As research continued, scientists began noticing inconsistencies. Geological scans revealed unexpected gaps. Some underground spaces appeared larger than current models predicted. In other areas, ground density measurements did not align with known rock formations. Gravity readings shifted subtly across short distances. These changes were small, but they were consistent. In certain locations, water loss exceeded all reasonable geological explanations. This does not suggest anything supernatural. There is no evidence of unknown forces or impossible physics. Instead, it highlights a different problem. Our maps of the subsurface are incomplete.
Large portions of the Earth remain unseen, unmeasured, and poorly understood. What makes this phenomenon especially significant is that it is not isolated. Similar cases have been documented on multiple continents: in Europe, in Asia, in Africa, and in the Americas. These locations do not share the same climate. They do not share the same rock formations. And they evolved under different geological histories. Yet the outcome is strikingly similar. Water enters the ground, and it does not return where it should. This repetition suggests a broader process at work, one that operates quietly, slowly, and far below the surface. Water is essential to life on Earth. It shapes terrain, feeds ecosystems, and connects the surface to what lies below. Yet in these locations, it behaves differently, as if the planet itself is redirecting one of its most vital resources. Until science can fully map what exists beneath our feet, these disappearing rivers remain unexplained, not as myths, not as legends, but as open questions. Questions that remind us how much of our own planet we still do not understand.